Welcome to Lab 1 of Physics 2. So the objectives for this lab was to estimate the charge on different pieces of Scotch tape, or as we called them, U-tapes. Then we had to determine the excess charge in the tape after the interaction with the other piece. We then also had to estimate the change on the charge and then the transfer of the electrons. So, for Coulomb's law is one of our main key ideas. And that is force is equal to K, which is a constant, times both of the charges over distance squared. K here we use is 9 times 10 to the 9th Newton meter squared times Coulomb squared. Then we use the electric field of a point charge equation, which is the same K times the charge over the distance squared times r hat. Then we also used the force and electric field equation, which is force is equal to the electric field times the charge. And then we also use the force due to gravity, which is force equals mass times gravity. For the experiment, we used two pieces of tape called U-tape. We measured them. The length of the U-tape is 0.2 meters. The width of it is 0.018 meters. The mass of it was 2 times 10 to the negative 4 kilograms, and the distance between the A tape and the B tape was 0.0035 meters as we measured. Then for the calculations, this first one is the charge on tape B. The equations that we used was the net force is equal to the force of gravity plus the force of the electric field, and that was all equal to 0. So we found out that the magnitude of the force of gravity is equal to the negative electric field force. Then we substituted in our equations as from the previous slides, and then substituted in our numbers, and we got that the charge of the B tape was 2.33 times 10 to the negative 9 coulombs. Then we did the calculations for the number of electrons and atoms on the tape B. For the number of electrons, we simply had to do the charge of the tape B divided by the charge of one electron, and so we got that there was 1.456 times 10 to the negative 10 electrons. Then for the number of atoms, we had to find the area of the tape, and then we divided that by the approximate area of one atom, and then we got there were 3.6 times 10 to the 17th atoms on the tape. Now for our computational model. This is the code that I figured out. So we have the constant K, the electron charge, and then we have the mass of the tape, the distance that the tapes A and B were together, a scale factor of 10, and then G is negative 9.81. So then we found out the charge on the tape using the equation for the electric field as in code, and then the last part was the making the computational model look right. So we had two different spheres and then errors coming off of those spheres. Now for the computational model, this is what it looked like, and then we see that the charge on one piece of tape is 1.634 times 10 to the negative 9th coulombs. So for results and discussion, the question we had to answer was, what assumptions, approximations, or idealizations did you have to make to determine approximately the amount of charge on the floating tape? Select all that apply. Ignore air resistance on a moving object, and I decided that this was not the case because the U-tape of tape B was static, and it did not move at all during our experiment to be able to care about air resistance. The other next one was treat a long tape as though it were a point charge with all the charge concentrated on the center of the long tape. And the other one is assume that each U-tape you made had about the same amount of charge, evenly distributed along the length of the tape. Those two are the ones that we had to focus on because otherwise it would have been too complicated to figure out if the charge wasn't located in one center point and if the charge wasn't the same. Then for the what if questions. What if electrons had positive charge and protons had negative charge? What would change about the observations made with your tapes and other charged objects? And the answer is that there would be no change. It would have an effect in the real world, but not in the experiment because they would still repel each other. If they were like charges, repel always. It wouldn't suddenly change that. And why is it important to handle the charged tape as little as possible? What happens when the charged tape come in contact with your hands? The handling of the tapes allows excess electrons to accidentally escape or new electrons on the surface to flow in, so handling them as little as possible so as to maintain the charge was of the utmost importance. Thank you.